Okay, so you have done a little bit of a review or a prep for this circle geometry unit. Now we are ready to get going on it. This is uh, this is about tangents and how they work with circles. So first, before we get into this, we need to do some more practice and prepping and review um, our good friend the Pythagorean theorem. So I'm going to go through this really quickly. You should already know how to do this. And if you forget, watch a previous video on this. So Pythagoras, or the Pythagorean theorem, is a squared plus b squared equals c squared for a right angle triangle. They don't show the boxy thing there, but that is a right angle triangle. Trust me. Just pretend there's a boxy thing there. Where the square of a plus the square of b gives you the square of c. That's what that formula means. And it only works for right angle triangles. And so just really quickly, here's how you would figure out this missing side. If you remember, there's the right angle triangle, which they're not showing. They're being bad, but just pretend it's there. So to find this missing side, how would you use this? We use this formula, a squared plus b squared equals c squared. There's the A. The A and B, remember, don't matter which order they're in. That could be A, that could be B, or vice versa. The C is the important one. It's the boxy thing always points to the C. And you square both sides. Remember, this is not 12. My God, please don't do this anymore. It's 6 times 6, and that's 4 times 4. And you add those two up, you get 52 equals c squared. We want to get c by itself. We have to square root both sides, and you're left with that missing side being 7.2. Over here, same sort of thing. Actually, not quite the same thing. Here they... Sorry, this is bugging me. I need to put the boxy things in. There's the boxy thing. There's the boxy thing. There's a boxy thing. Here, they tell you the C side. So this is one of those questions where you got to slow down and not just use this formula. You got to think. They give you the C side, so we're going to know that number. We're going to know the let's call this the B side. We don't know the A side. So there is our formula. Again, you don't have to call it A. You can call it x squared like they do here. And set it up like that. So 10 squared 100 equals 144. We have to get this x squared by itself. Let's get rid of 100 from both sides. Subtract 100 here, subtract 100 there. You're left with x squared equals 44. Find the square root of 44. It's 6.66. Really quickly, I'm going to show you, and you can prove these yourself. There's things called Pythagorean triples. They're triples or right angle triangles where you get whole numbers each time. Like the last two, you got a decimal for the answer. Well, these ones always give you whole numbers. So there's the famous 3, 4, 5 triangle, where with one side is 3, one side is 4, the other side will be 5. The hypotenuse will be 5. The 5, 12, 13 is another Pythagorean triple. Here's the proof of that. So if you square these two together, 3 squared plus 4 squared, you should get 5 squared. Let's prove it. Well, 3 squared plus 4 squared is 9 plus 16, which is 25, and that equals the other side. The same thing would happen if you did this, did that with these three. Really quickly, to show you what the missing sides for these guys would be, I'm not going to go through it all in detail. It's actually not a bad idea to kind of memorize these because it kind of saves you a lot of time when you see it. 3, 4, 5. That's the same triangle or situation there. The 5, 12, 13, like I said. What do you think this side's going to be? Well, yeah, 5, 12, 13. So that's going to be 12. And again, if you don't believe me, do it yourself and figure it out. 6, 8. This side is a 10. Trust me, do Pythagoras, and you'll get that. And then here, 7, 24. This other side is going to be 25. Okay, so Pythagoras. Really quick review on that. Let's move on to what a tangent is. A tangent, here's the wordy definition they always give you. And they say that a tangent is a line that intersects a circle at exactly one point. What does that mean? Here's a circle. There's a line. That line touches the circle just at one point. So that's a tangent. So it touches, where it touches, it's got a special name for it. Okay, so that's a tangent. That point where it touches is called the point of tangency. I wouldn't worry about that too much. It's just, as long as you know this in your own head and in your own words, don't get too bogged down by the terminology. Would that be a tangent? Would that be a tangent? Would that be a tangent? Remember, it has to intersect a circle at exactly 1 point. And so that's not a tangent. This one is not a tangent. This actually is a radius, if that's the center of the circle. That's not a tangent. Okay, so when math people name tangents or any line segment, they use letters as the endpoints. So, how many tangents do you see on this circle? Well, before I get that, just the naming system. A line from point A to C would be called this. The way they show it would be a line on top, AC. Now you can switch around and call it CA if you want. It means the same thing. But that is a tangent because it touches just at 1 point. That's a tangent. Green tangent. Yes. Another one. Let's see if you can find some other ones here. What about EC? Would that be a tangent? Yes, it is. That purple line EC, which you could also call CE, would be a tangent. Remember, that's how you write down line segments. A line on top and the letters that it connects from. Another one would be this red line here, CB or BC. And then FC or CF is also another tangent. So those are tangents. Those other lines were not. What's so special about these tangents? I will tell you one thing. A tangent is perpendicular to the circle radius at the point where it touches the circle, or the point of tangency. Here's what I mean. There's a circle. There's a tangent. If I were to draw a radius, which is again halfway from the center of the circle, what they're saying is that that line and that line are straight up and down. They're perpendicular. And what do you know about perpendicular lines? You should know that perpendicular lines are 90 degrees to each other. So that line is 90 degrees to there and also from there as well. So if OB is a radius, they always use O as the center of the circle, and AC is a tangent, then OB is perpendicular, right angles, to AB. Okay? At that point of tangency, and they drew it in the boxy thing, but whatever. Here's another one. There's a tangent, there's a radius, and so if I were to make a triangle out of this, like that, what would we know about this triangle? Well, if that's a radius, that's a tangent, that means that's 90 degrees, that's 90 degrees. We've created a right angle triangle there. Now, they name triangles, just like you can name line segments, you can name triangles as well. It doesn't really matter what order you call it, OBA or ABO or OAB, that would be one triangle. Another one would be OBC or COB, doesn't matter the order you do it in. So then triangles from there would be right angle triangles. You can see why Pythagoras might come in handy then. That's why we did that little introduction at the start. So both triangles are right angles. They both have a 90 degree. Okay, so what's that 12 doing there? Here's another rule. Two tangents from the same exterior point to a circle are equal in length. Now before you start throwing things at me, here's what that means. So there's a circle, there's an exterior point, some outside point. If I were to draw a tangent from there to there and there to there, the point at which it touches the circle to that outside point, touches the circle to that same outside point, those two lines are equal in length, which is handy to know. So there's the lines. There's the exterior point. What we're saying is AC is going to be equal to CB or BC. They're both tangents. they're both equal to each other. Now, that's not going to work for DC. That line is longer than that line. It only works from the point of where it touches the circle, which they call the point of tangency, to that exterior point. Okay, so those two are equal. The green line and that green line. And then the little line there to show that they're both equal. Okay, let's play with this. So there's an exterior point. There's a point of tangency, another point of tangency. If that's 12, what length must this be? Well, according to this rule, it should be 12, shouldn't it? And it is. Okay, how about here? XY. We don't know what XY is. There's the exterior point. WX shares that exterior point. So that's 9. That should also be 9. And it is. Let's do the next two together. WV and VT. Well, if that's 14, and that shares the same exterior point, that must also be 14. There you go. And if that is 10, TZ, YZ, because it shares the same exterior point, must also be 10. Alright, let's play with this knowledge. Okay, so here's a diagram. I would draw this as best you can. Pause it if you have to, and try to figure this out on your own if you can before I give you the answers. I want to figure out angle X, angle Y, and this unknown side Z. Using all the rules we have so far. Well, what do you know about X? Well, what I know first is that's a tangent line, and that's a radius. And what do we know about radius and tangent lines? They always are perpendicular to each other, which means that this, and more importantly that, is 90 degrees. So I'm not going to write in the box because they will give you the answer. X has to be 90 degrees. And the reason why, I'll let the neater printing of the computer tell you why, or write it out for you, but the reason is because a tangent meets a radius at 90 degrees, or the tangent radius rule, which means a tangent and radius are perpendicular to each other. That's 90. What's angle Y going to be? Now, hopefully, you've done a little bit of work with triangles. You should know that the angles in a triangle always add to 180. So if we know that is 90, that's 35. What must this be? Well, you just go 180 minus what I just said, 90 plus 35. If you don't like the way I'm doing it here, and you can do it your own way, I don't really care. Just get the answer. That's 125. So you go 180 minus 125 to get your answer, which is 55. So according to that, I would think that Y is 55. Alright, now, how do you figure out missing side Z? Okay, well, that's a right angle triangle right there. See that? What do you know about right angle triangles? Pythagoras, my friends, Pythagoras. I'm not going to do it for you, but there's the 12, there's the 5. That side we don't know. The boxy thing is pointing to here, so that's the C side. A squared plus B squared equals C squared. Trust me, when you do all the work, or if you remember the Pythagorean triplets, the 5, 12, this is going to be 13. Now if you don't know how I got that, just do A squared plus B squared. You'll get C squared, and you get the C to be 13. Let's see if we're right. So X, like I said, is 90 degrees because of that radius tangent rule. There's the tangent, there's the radius. When they meet, it's 90 degrees. Y is 55 because angles in a triangle add to 180. Hopefully you've come across that. It's a handy rule as well. So it is 55 degrees because angles in a triangle add to 180. So we knew it 180. We knew one side was 90. We knew the other side was 35. So the difference is 55. And Z is 13 because of Pythagoras. Okay, now let's take a look at the next one. What about this one below? Let me erase all of that. What about this one here? Okay. X, Y, and Z. There's X, there's Y, and there's Z. What do we know about these guys? Okay, so first, we know that X, well, actually there's a tangent and there's a radius. Maybe thinking, how do you know it's a radius? If it's from the center of the circle, which they always label O, and they put a dot in the middle, that's a radius, that's a tangent. We know that's 90 degrees, and that's 90 degrees. So right away we know that Y is 90 degrees. You don't have to go in the order of the thing. You just write down what you know, and you can figure it out. Well, if that's 90 and that's 65, we can figure out X because, remember, angles in a triangle add to 180. What's 180 minus 90 minus 65? Do it yourself, work it out. It should be 25. So X is 25. Y is 90 because of the tangent radius rule. What about Z? Well, this side's 90 because the radius tangent rule. That's 25. Just go 90 plus 25 minus 180, or 180 minus 25 plus 90. And you should get the missing Z number, which is 65. Trust me. Okay? So again, if you're not really getting what I'm saying here, there's the triangle. We know the whole thing has to add to 180. We know that that's 90. We know that's 25. So what's 90 plus 25? 115. 180 minus 115 gives you, trust me, 65. Let's see if we're right. We should be. X is 25, like I said, because angles in a triangle add to 180. Y is 90 because of the radius tangent perpendicular rule thing. And Z is 65 because, again, angles in a triangle add to 180. Alright, moving along. Let's take a look at this nasty question. Okay, so, again, in these problems, write down what you know. So, that's a tangent, there's a radius. I know that's 90 degrees. There's an exterior point, there's tangent, tangent. So I know that side is 12. This side must also be 12. So I've already knocked down what Y is. Y is 12. I got to figure what X is. How am I going to do that? Well, right angle triangle. That side's 5. That side's 12. There's the boxy side pointing to that. So that's the hypotenuse. I remember my Pythagorean triples. This is the 5, 12, 13 triangle. And if you don't believe me, then on the side, do a squared plus b squared equals c squared. And then do all that. Put 5 squared plus 12 squared. You'll get 169. Square root both sides. You'll get 13. I know it's 13. Let's see if we're right. It is 13, and we use the Pythagorean theorem to get that. Y is 12 because of that exterior point rule. Tangents with an exterior point are equal. Okay, how about this one here? This one's a little trickier. So with X, which is right here, what do we know about it? Now this brings up another rule which you may not be familiar with. Before I get to that, let me just talk about what we know. There's a radius, there's a tangent, 90 degrees. There's a radius, there's a tangent, 90 degrees. There's an exterior point, there's a tangent, that means whatever Y is the same as this. So these two lines are equal. So I can kind of see ahead here what I can do a few things. Let me first go after Y. To figure what Y is, we can try to use Pythagoras. Now this side, they tell us, there's a few ways to do this. You can figure out that that's, or know that that's 9, that's 15, And then we can use Pythagoras to figure this side out. And since this side's the same as that side, we can figure out y. Or you can realize that that's a radius 9. That's also a radius, which also has to be 9. And then you can do your Pythagoras thing. 15 there, 9 there. This is one of those Pythagoras triangles, Pythagoras triples, where there's the hypotenuse 15, 9. Trust me, if you do the whole a squared plus b squared equals c squared, you will get that y is 13. Sorry, y is 12. Y is 12. Trust me, it is 12. I think you're big kids. You don't need me to do all that work for you. Trust me, it is 12. Okay, so y is 12. That's also 12. Exterior point. Now the tricky part is that angle there. We know that's 90. Is there any way we could figure out what that angle is there? Well, they tell you that that's all 250. Do you know how many degrees are in a full circle? Well, there's 360 degrees in a full circle. If that's 250, that means the leftover is 110 degrees. 360 minus 250 is 110. This line is cutting that right in half. So that means this is 55. And that's 55. So this 90 plus 55 minus 180, or properly said, 180 minus 90 and 55 gives you 180 minus 145, which is going to be 35 degrees. Let's see if we're right. Yeah, trust me, it says 35 there. And because angles in a triangle add to 180. This whole rule that I just explained here. That's a tricky one, because you have to know that angles in a circle add to 360. And then y is 12 by using the Pythagorean theorem. Okay. This guy here, I'm going to go through it really quickly. It is a little bit tricky, but I am running out of time. So, if you're given CD is 10 and AB is 26, what would AP be? Okay. So, if CD is 10, and CD would be a diameter of that inside circle, that means the radius from there to there. Remember if you remember, the radius is half the diameter. Diameter is the full distance across. Radius is half the distance across. That's 5. That means that OD is 5. CO would be 5. We're just writing down what we know. This full length is 26. That's the diameter of the outer circle, which means the halfway across is going to be half of that. That's 13. That's 13. If that's all 13, we know that's 5. The leftover is 8. Right? We can figure out what AP is because there, center of the circle to P would be a radius. Tangent radius, that's a right angle. Here's something else we know. From there to there is 5. Any line from the center of the circle to that point is also going to be a radius, so that's also 5. So we can figure out our right angle triangle by realizing our tangent radius rule. That's 5. That's 13. 5, 13. And there's again our right angle triangle right there. We have to figure out what this side is. Well, maybe you remember the Pythagorean triplets. This is a 5, 12, 13 triangle. Or again, if you don't believe me, do it all. To get that missing side, you do Pythagoras, and you will get that. which, like I told you, is 12. Okay, so there you are. Here is your skill tested question right here. I want you to tell me what x and y are. Missing angle x and missing side y, using all your tangent stuff. Thank you very much. Goodbye.